Hello everyone, I am Dr. Abakumari. Today we discuss some more problem from the chapter area of curve. So here we have taken the question, find the area of the loop of the curve y square equal to x into x minus 1 whole square. Okay, so let us see the solution. First we discuss about the tracing of this curve. So how can we trace the curve of y square equal to x into x minus 1 whole square? So here the first point is the curve is symmetrical about both the axes. About the x-axis, okay, about the x-axis, y-axis, because while substituting x equals to minus x, what we see here is about the x-axis. And the second point, now the second part of the curve is the curve passes through x equals to 0, x equals to 1, okay, and y equals to 0. While putting y equals to 0, we get x equals to 0 and x equals to 1. And while substituting x equals to 0, we have y equals to 0. That is, the curve cuts the y-axis only at the origin. Fine. And x-axis at x equals to 0 and x equals to 1. Fine. And we'll also see the curve passes through x equals to 0 and y equals to 0. So number 3, the curve passes through the origin. Passes through the origin. Since we have seen here the x equals to 0 and y equals to 0, we are getting the 2 points in the x-axis and the y-axis. Okay. Now next. While putting the x equals to minus 1 and y equals to minus 1, we get both the value of x and y as imaginary. So the negative value of x and y is imaginary. Okay, so the points that is the curve, the part of the curve, that is the part of the curve is on the left hand side is on the left hand side of the y-axis. Fine. So let us see the figure which we are getting here. So therefore the required curve is as follows. So here we have a x-axis and the y-axis. These are origin, the x-axis, x dash, y. Now here is y dash. Okay. So the points here is 0 and 0, and only one point is here is 1 and 0. And no point is on the left hand side of the y-axis. So our curve is like this one. Here it cutted the x-axis both at the point 1 and 0. Okay, the same point. Okay, and since it is symmetrical about the point, okay, the curve is symmetrical about the x-axis and also on the y-axis. Therefore, the required equation of the curve is become, therefore, the required area is 2 times, okay, integration y dx from what, if we have this one OA, then this is O2 OA, that means 0 to 1. Okay, so this is equals to 2 times 0 to 1, Now what is our y? So here in the question the y is root x into x minus 1. This implies this value is your y. So we will put this value here in the form of the y. So what we get here is root over x square and x minus 1 ka whole square into dx. So this is becomes 2 times 0 to 1 root x, x minus 1 and then dx. So while solving this problem, what we have here is 2 times 0 to 1. We get here is x to the power 3 by 2. While multiplying this value, we get x over 3 by 2 and minus x to the power half, and then we have dx. Now integrating, we get this is 2 times. Now x to the power 5 by 2 and divided by 5 by 2 minus x to the power 3 by 2 and divided by 3 by 2. From the limit is from 0 to 1. So what we get here is this one is equals to 2 times. This we get a 2 by 5 minus here we have 2 by 3. So this will becomes 2 times. Now 15 is in the LCM. So here we have 15. So 3 to 6 and then we have minus. So here is minus. This is 4. So this is 2 times minus, sorry, here is 10. So minus 4 divided by 15. But since we are talking about the area, so this is equals to what? Minus 8 by 15. But area we cannot give in the negative form. So the required area is your 8 by 15 square unit. Here is the answer. Okay, thank you.